Okay, let's carry on with our discussion on 2022 October, November, paper 21, number 4. Okay, just to review that. Polarization is a phenomenon associated with light waves, but not with sound waves. State the meaning of polarization. Right? Oscillations are in a single direction, which is perpendicular to the direction of propagation of the wave. Memorize it. Or oscillations are in a single plane, which contain direction of propagation of the wave. State why light waves can be plane polarized but not sound waves. Light waves are transverse, sound waves are longitudinal waves. Two polarizing filters A and B are positioned so that the planes are parallel to each other and perpendicular to the axis of line XY. Right? That's your XY. There's your this unpolarized path to the filter. So that's it's polarized vertically. There's your I naught. And it passes through the second filter, which is a horizontal axis. The transmission axis of filter A is vertical, and the transmission axis of filter B is horizontal. Unpolarized light of single frequency is directed along the line XY from a source position at X. The light emerging from filter A is vertically plane polarized and has an intensity I naught. Like coming out of filter A is plane polarized, intensity is I naught. Filter B is rotated to a position along XY as shown in figure 4.1. After rotation, intensity of light emerging from filter B is a quarter I naught. Calculate the angle or rotation of B from the starting position. Okay, so if it's vertical, then this one becomes horizontal, then this one will be 0 lah. But now you want to find the intensity is that. So you have to memorize Mahler's law. Remember this formula. Right? Same is I naught. I1 is given you. That's your I1. So you want this angle. Right? So take I naught down and square root it and put in your value. I1 is a quarter. I naught cancel 0.5. Okay. Anything you don't agree?
Okay. Oh, by the way, teacher, what's this paper again? 2022 what ah? Summer or winter?
October, November, so it's winter.
Winter one what? Winter two one ah. Okay.
2-1 lah, winter 2-1. Okay, so that's your angle of rotation. It can be 30, it can be 150, and 210, and 230. They are acceptable answer. Any comment or anything you want to ask?
No.
Okay.
You should, okay.
Yeah.
No.
a microwave of intensity I naught and intensity A naught meets another microwave of same intensity, same frequency, sorry, and of intensity a quarter I naught traveling in opposite direction. Both microwaves are vertically plane polarized and superimposed where they meet. Explain without calculation why the two waves cannot form a standing wave with zero amplitude at its node. Okay?
Different
Okay.
amplitudes cannot form destructive interference.
There's two mark, so you have to be careful that you have to do two point.
Different amplitude is one.
Yeah. The wave has different amplitude, one mark. Cannot have a resultant. Yeah, different amplitude. Why? They cannot have a resultant. There's always zero. Or cannot have a complete destructive interference at the node source. Right? There's your two mark. Lor. Determine them in terms of A naught, the maximum amplitude of the waveform. Right? They just want you to use this formula lah. I is proportional to amplitude square. So A2 square or I2, A1 square or I1. Right? So A2, take I2 across there, get this equation. And I1 is the original one. This one is I2. Sorry, this is I2, yeah. Right? I2 is a quarter. So you get our answer. So maximum amplitude is A naught plus half A naught. This 1.5 A naught. Okay with that?
Correct.
Okay. State Ohm's law. Yep. Can remember?
Yeah. Current directly proportional to the potential difference across conductor,
Condition?
provided that the temperature remains
Okay.
constant.
Current to a conductor is directly proportional to potential difference across the conductor. How come I think you have to add in provided temperature remains constant. Okay, that's your graph. Relation of current I and potential difference across a filament length. The resistance of filament length increases the potential difference. State how figure 5.1 shows this. Yep. Resistance is V over I. So look at the ratio of V over I. V over I is a reciprocal of the gradient from of a straight line. from
Resistance increases, like the ratio VOI increases as
VOI
PD increases.
ratio, VOI increases. Provide the temperature of the conductor remains constant, ratio of V over I increases as PD increases. Explain why resistance varies this way. Yep, can.
Yeah. When the potential difference increases, current increases, and the temperature increases. So
As PD increases, current increases, so temperature increases. Okay, can.
mm.
Either PD increases or current increases, the temperature will increase. Okay, let's go to the next one. Figure 5.2 shows a circuit with a battery of electromotive force 12 volt connected to a linear potential divider AB. The battery has a negligible internal resistance and the lamps have a same IV characteristic as shown in figure 5.1. Right, that's the graph. When the slider of the potential is at the midpoint, as shown in figure 5.2, the current in the battery is 1.78 ampere. Determine the current in P. How to do that? Yep, yep. How to do that?
uh, Look at the graph.
How?
6 volts. 6 volts. 1 point.
Basically, 12 volt is across these two lamps. They are equal resistance. So you look at the 6 volt, 6 volt there.
Yeah, 1.5.
Look at what is the current.
About
PD across
1.5.
each lamp is 6 volt. Current is 1.55 ampere.
Okay.
Okay,
Hmm.
total power dissipated in lamp P and Q. Right? We have calculated. This one is given. This one we have read from the graph. So how to calculate the total power dissipated in lamp P and Q? Basically trying to get you to use a formula for power. Yep. What formula to use? Got the voltage. You got the current. So what's the formula to
E
use?
equals IV.
Hmm. E equals IV or VI. Put in your value. Right? There are two of them. Both the same. That's why it times 2. And then V is 6 volt. I is 1.55. So you get 19 watt. The resistance of the resistance of potential divider between its ends A and B. How to calculate that? I always remember to draw what is given on the diagram. It's okay to draw on the diagram. Doesn't say you cannot draw. And from there you can see what is happening. Yep, can.
Yeah.
What should I
I
do?
got. I took 12 over 0.23. I find the current first. 1.78 minus 1.55.
Okay, you got the current coming here. branch out to here, and then the other one branch out to here. So you have to use Kirchhoff's first law, lor. Calculate the current through here, lor. Right? Current through the potential divider is 1.78 minus 1.55 is 0.23. Then the potential difference is 12 volt, or EMF is 12 volt. Right? R is V over I. So it's 12 over 0.23, 52 ohm. Okay,
Mm.
the slider of potential in C is moved to NA. State and explain the effect on the brightness of lamp P and Q. Yep. Can apply, explain, applying your knowledge.
When it's a NA, then the P goes out. Then P goes off.
Okay, P goes all good. Thank you.
And, uh, Q gets brighter lah. One is like remove. There is one get brighter, one get dimmer.
You didn't explain why, ah. You just tell
Oh,
me. You just state only. So you probably get 1 mark only. Right? One
because
potential difference is
the
zero.
potential difference, yeah,
Ah,
potential difference increase in lamp Q ma.
right? Decreases to zero. So it goes out. PD across increases to 12 volt. So it gets brighter. Right? PD across lamp Q increases to 12 volt. So it gets brighter. Any comment or anything not clear?
No,
A lepton is an example of fundamental particle. State what is meant by fundamental particle.
fundamental particle is like the smallest particle, right? You say right, it's the smallest form already.
Particle,
Like
no internal structure. Particle which cannot be broken down into anything smaller. It's the smallest, cannot be broken into smaller one. As far as we know lah, right? That is where our knowledge is. Last time it was the atom, then it becomes proton and neutron. Now we come to lepton and quartz. Okay, a lambda particle, I don't teach you also all this, but you have to, it's a hadron they define for you. Consists of an up quark and a down quark and a strange quark. Show that the charge on the lambda particle is zero. So up quark is what? How many E? Can remember how many E? What's the charge on the up quark?
charge of the up quark, one third.
Up quark is 2/3 E.
Actually, sorry.
Down
That's
quark is
the
minus 1/3.
yeah.
Right? Charge in up
That one
quark,
is mine. Yeah,
M minus 1/3, minus 1/3. Strange is minus 1/3.
zero.
So you add them up, zero. Okay,
Mm.
lambda particle is unstable. It can decay into a neutron and a pion as shown by the equation. Pion particle consists of an up quark and an anti quark. Compare the properties of quark and an antiquark. Yep. What can you say about that?
Compare the properties.
Hmm.
I just put the number, the electron, 2/3 and minus 1/3 can.
They have the same mass, a different charge, opposite charge,
Oh,
same
yeah.
magnitude.
Same as.
Ah, same or equal mass, same or equal magnitude of charge,
Both are also
fundamental
fundamental
particle,
particles.
opposite sign of charge.
Yeah.
One is matter and one is antimatter. Right? So any of these, so any two of these, so 2 marks. Explain why neutron is classified as baryon and pion particle is classified as meson.
I only remember neutron is baryon because it has 3 quarks, but the other one I don't know.
The other one is a quark and antiquark. Neutron
Oh, one
or
quark and
baryon
one
consists
antiquark.
of 3 quarks. Pion or meson consists of 1 quark and one antiquark. Okay?
Yeah.
Okay, we have completed this one. Okay, is that what you want to discuss this one?
Yeah, we
24
can start with paper
May.
1.
This one is summer. 24, 2024, May, June, paper 1 and paper 2
Yep.
Okay, let's carry on. What's happening? That's the answer. Which unit is a SI based unit?
It's base unit where so I put ampere.
Good. Ampere.
The teacher, if it's Kelvin, then it's the SI base unit, right? Celsius is not.
Celsius is wrong. I should be Kelvin.
Kelvin,
It's wrong.
okay.
I should be kilogram. Then this derived quantity, Coulomb, derived unit. Which of the following could have the same unit as force?
A.
Just remember, work done is force times this displacement. So as far as when it comes to unit, work done or energy is the same thing. Right? A, good. The velocity of an object changes from initial velocity u to final velocity v. The vectors represent the velocity, right? These are velocity. Which single represent the change in velocity in the object? What's your
Boy.
answer? Right? That one start with v minus u. Okay, wrong. Should be cat. Where did you go wrong? You didn't put negative sign, I think. Okay,
Yeah.
careless.
Wait. Teacher, can you explain? This one I like
Negative,
because
yeah,
I
it's
thought it's
v.
like
You start with v, and negative of u. U is this way, negative of u is the opposite direction. No? Then where you start,
oh
where you stop, you draw the line. No? There's a change in velocity. No? Can
okay,
anything still
yeah, I
not
get it, I
clear?
get it. I get it already.
Okay. An object moving with a initial velocity u, object then move with a uniform acceleration a for time t until it reaches a final velocity v. Which equation describes the motion of the object?
Boy.
Boy, memory word only. Which calculation produce a vector quantity?
Boy.
Okay, good. Both are displacement. So the resultant is also display the vector. Thermometer can be read to an accuracy of plus or minus 0.5 degrees Celsius. This thermometer is used to measure a temperature rise from 40 to 100 degrees. What is the percentage uncertainty in the measurement of temperature rise? What is your answer?
C.
Right? Percentage uncertainty in X. Right? The difference is 100 minus 40 is 60. So you add each of them got 0.5, 0.5, so it's 1. The percentage uncertainty is 1 over 60 times 100, 1.7. Donkey. Can anything
Yeah.
still not clear? Can let's carry on then. Diagram shows the path of golf ball. Which row describes the change in horizontal and vertical component of the golf ball velocity when air resistance is ignored?
Oh yeah, C.
Okay, we got 10 more minutes.
Cat.
D, okay? Cat, what? Correct? Aircraft flies from London to Sydney in a time of 21 hours, 40 minutes. The distance traveled is 17,000 kilometers. What is the average speed of the aircraft? It's very simple lah. That's why we play with the unit that's all.
C.
Calculate that, you x over t, right? 17,000 kilometers, change it to that. And 21 hours, 3 times 3,600, 40 minutes times 60, so 220. C, okay, good. A golf ball hits a golf club hits a golf ball. The graph shows how the force on the ball varies with time t. Which graph shows how the velocity of the ball varies with time?
Donkey.
C, is it?
Donkey. D.
Donkey. You get caught already like me. Right? This is force time graph. So you can think of it acceleration time graph. This is accelerating. This part is still accelerating. Right? But a different magnitude, that's all. Right?
Oh shit.
Increasing magnitude. This is decreasing magnitude.
So I think it's C, right?
No. The velocity must keep on increasing.
Oh.
B. Okay now. Velocity must keep on increasing. Then it becomes 0. That is 0. Horizontal. The gradient is 0. Okay. Increasing. And after that, increasing smaller value. Right? This is the maximum. After that, increasing smaller. And after that, 0. Zero here.
Oh.
This is a repeat question now. Old question, repeat. What is meant by mass and weight of an object on Earth? Memory work. What's your answer?
Donkey.
Okay, good. A thin horizontal plate of area 0.036 meters squared is beneath the surface of a liquid of density 930 kilogram meter minus 3. The force on one side of the plate due to pressure on the liquid is 290 Newton. What is the depth of the plate beneath the surface of the liquid?
A. Wait, what? Oh, yeah.
Yeah, instead use a definition. Okay, good. Any comment?
No.
Okay. This one you must know relative velocity of approach. Same direction to approaching each other, and then after collision they move in different direction. There's a you just add them up, easier to remember. Relative velocity of approach, relative velocity of separation. So
Ini jadi manusia minta dihargai sama macam sungai.
if it's completely different, then you have to give negative sign. No? So what's your answer for this one?
Boy.
Okay, why? Good. Answer for this one?
Donkey.
Draw the diagram. Okay, good. Donkey. Stop me if I'm going too fast, if you need any clarification. Usually they won't worry about negative sign right? Unless they put the answer left or right. This one is A, 14, okay? Can or not?
Yeah, can. So I put A.
Moment equals to force, right? Force times, you want the vertical force, vertical component times that perpendicular distance. That's what is happening. I take moment about S. A, okay? Good. Any comment?
Oh.
Yep. What's the answer?
Donkey.
Right?
Oh,
Horizontally is there's a T cos theta for this one, T cos theta for this one. That's why it's 2 and cos theta. This is 10, this is 8, this is 6. So cos theta is 6 over 10. B. Okay,
hmm.
a box of weight 40 Newton is pushed with a horizontal force of 20 Newton along a level ground for a distance of 2.4 meter. The box is then lifted at constant velocity through a height of 1.6 meter by a vertical force. What is the total work done on the box by the two forces?
Closest answer I got is boy.
Right? Have a picture of what in your mind if you want to draw. Just have a picture of what's happening. Total work done. Boy, okay, good. Memory work.
A.
Okay.
Boy.
Okay, good. 20.
D. Donkey.
B.
Oh,
Okay. Any comment?
wait, can you explain?
Okay, after a steel ball is falling at constant speed. Constant speed means constant kinetic energy. Which graph shows the variation with time of the gravitational potential and the kinetic energy of the ball. So answer can only be A or B. Right? Potential energy is the straight line. Initially, it is high. Then as the ball drop down, the height decreases, so potential energy decreases. So the answer is B. Can
Oh, because velocity is constant.
velocity is constant.
Oh, okay. Yeah, I get it. Because I put D because I thought change in this